Okay, I wanted to do a video that's kind of in between the end of 12.3 and a little bit of the preliminary requirements to do the beginning of 12.4. So the end of 12.3 we left off with an exercise, which was if u was the vector 1, 2, 3, and v was the vector 0, 1, negative 1, what is the component or the scalar projection of u onto v, and the vector projection of u onto v. And remember, this was u dot v over the length of v. So this is just, well, u dot v is 2 minus 3. That's divided by the length of v, which is negative 1 over the square root of 2. And the projection of u onto v, that's u dot v divided by v dot v times the vector v. So u dot v was minus 1, v dot v is 2, and the vector v itself is 0, 1, negative 1, and hence we get 0, negative 1/2, comma 1/2. Okay, so this is the actual vector itself, and it has length. It's pointing in the negative direction, so this component, the absolute value of the component, is the length of this vector. So let's go ahead and do a little bit of preliminary work. By the way, in 12.3, there's a little bit of something I skipped, which is about work, or computing the work done using dot products. And it's a useful thing, especially if you're going to be looking into doing some physics stuff or maybe some mechanics. Yeah, I skipped this, but it's for those of you who are looking to do something more physics related, you may want to just at least read that part of the book. If you have any questions about it, you can ask me during my office hour. Okay, so let's move to 12.4. And before we start it, I just want to do some preliminaries, which is on what's called a determinant. Preliminary. I just want to define in this video the determinant for a 2x2 or a 3x3 matrix. So a definition. And for now, let's just, the motivation comes from linear algebra, solving systems of linear equations. But for us, let's just think of it as a formula. So given a matrix A11, A12, A21, A22, its determinant is, well, we're going to denote it det of A11, A12, A21, A22, which in calculus we tend to just put square a kind of straight line here, A11, A12, A21, A22, so we don't have to write the det every time. And that is A11, A22 minus A21, A12. It's essentially the product of the diagonals and then subtracting the other product here. A lot of times, well, maybe it's easier to see this way. Let's write the determinant of A, B, C, D as in this form, and this is just AD minus BC. It's also maybe a little bit cleaner way to write it. So this is for a 2 by 2 matrix. This is the determinant for a 2 by 2 matrix. Let's do the same thing for, so given a 3 by 3 matrix. Well, before I jump to that, let's do a little example here. So example, let's find the determinant of, say, the vector 1, 2, negative 1, 3. So that is going to be equal to, and in our notation, we're just going to write it as 1, 2, negative 1, 3 with straight lines on the sides. And that's 1 times 3 minus negative 1 times 2. So we get 3 plus 2, which is 5. Okay, so that's an example of a 2 by 2 matrix. So given a 3 by 3 matrix, I guess I'll write it out completely with letters A, B, C, D, E, F, G, H, and I. Its determinant is, and I'll write it with, again, the same thing, just with a straight line on the side. What is this equal to? This is equal to A times, and then in some sense we're going to cross out this column and cross out this row. And what's left over, we're going to multiply A by the determinant of that. So E, F, H, I. So this straight line is a determinant of this 2 by 2. And then we're going to go to the next item in that row. We're sort of expanding about this row ABC. So we're going to have a minus B. We always alternate signs. So it's positive A times it's what's called a minor matrix, determinant of the minor, minus B times, cross out the corresponding column, cross out the corresponding row. The minor becomes DF. Let me just write this with the same color to keep consistency. D, F, G, and I. And so now we've expanded about the second term. We have to expand now about the third term. So plus C, and then for C you cross out the column, cross out the row, multiply by D, D, E, G, H, that the determinant of that. So if you complete this whole thing, you get A times EI minus HF minus B times DI minus GF plus C times DH minus GE. Okay, so this is the determinant of a 3 by 3 matrix. Let's just do one example and then we'll stop here. So let's find the determinant. I'll just put it straight as the determinant of 1, 0, negative 1, 2, 1, 1, and 0, negative 3, 4. So what is this going to be? This is going to be expand about the first row, 1 times the corresponding minor matrix, which is right here. So we have 1, 1, negative 3, 4, minus 0 times the corresponding minor there. So the corresponding minor would be, we'll cross out here, so we're left with 2, 1, 0, 4, and then plus the last term. So let me erase these guys. Oops, I erased the 0 as well. So plus, and then the last term is a minus 1 here in that row, times the corresponding minor, which would be 2, 1, 0, minus 3. Cross out the column, cross out the row, and what's left. So what do we end up with here is the following. We get 1 times 4 plus 3 minus 0. This term just goes off to 0, and then minus 1 times minus 6 minus 0. So we end up with 7 minus 0 plus 6, so we get 13 overall. Okay, so I just wanted to show how to compute determinants in this video. We're going to be using that when we start 12.4. We will stop here for now and continue next.